you will get to idea about this thing. So let's go with the flow. We have something called as a KPI matrices, which we are going to be discussed. So for that, we have interestingly classical. I can say we have two types, right? Supervised and unsupervised. In that supervised, we have to specifically we are doing some of the case studies in terms of classification. Iris also some of the multi-class classification tasks, and this project is also the binary class classification task, which we already see in advertisement. It's going to be clicked or not. So, which we are going to be see what are the KPI metrics to evaluate, or how do we know this model is going to be works out very well for this model. So for that, we have the couple of the key matrices to help us to understand. Like first we have confusion matrix, and secondly we have something called F1 score, and precision and recall, and also the we can also call it as specificity and sensitivity. And third one is AOC ROC curve. So we are going to see these three in this notebook so that you will understand much better. So confusion matrix is all about it. It completely depends on something called matrix. So let me see that matrix. So this is just basic data. This is also some toy data set we are going to extract from UCI repository. I think you may aware it, right? I already shown the UCI repository. Yeah, this is this model building. We'll ignore this part just for now, just to understand the confusion matrix. How does this going to be looks like, and what are the different terminologies we have? So here we have some terminologies like true positive rate, and something called true negatives, and false negative, and false negative, and false positive, right? So whenever you encounter, we also predefined library for this confusion matrix from the matrices in the scikit-learn. So you can directly call it out, and also you have to be customizably implemented by using the definition. That is also fine. So let's go with the terminology. What exactly the true positive means? So you want to predict some disease. Okay, you want to predict some diabetics. Let's say for this example. So it's going to be give as exact result while completion of your model. So it's going to be give as the exact predictant. That I mean, your expectations must be matched with your model prediction. So it comes to under TP, that is the true positives. So the expectations may not be matched with your model result, that comes under in the true negatives. In terms of, I can say, true negatives is going to be help us to understand our model is not sufficient to predict those values, right? So these negative values may be affected to our model to some bad sense. And also the false positive will going to be help us, which is incorrectly classified in the actual results. So we have some data, but in the data we have predicted with false, I mean predicted with some not diabetes. So at the time we use it to predict by using this model. Let's say we are using here logistic regression, but this model give as the prediction is diabetes. At the time we use it to go with this false positive. It is not a actual. You can read like this: it is not actual, but it is predicted as a positive. You can read like this: it is not actual and it is not predicted as diabetes. So that's how you can remember it, so that you will also understand. Similar way, we also called as a type 1 error for FP, that is false positive, and type 2 error for the false negative. Some of the interviews may be asked with the type 1 and type 2 error. You have to directly say these things. So yeah, this is all about the confusion matrix. Under this, we will also get to know about more detail after completion of the basics of the Python. But just to understand about these case studies, I'm just going through the flow of the KPI matrices. So similar way, we also call it as TPR and FPR. So it is going to be given by using these operators only, whatever the operators we have, basic terminologies. So it's going to be look like TP plus TN, like true positive and the true negative, divided by these overall. So whatever the functions we have. So this is going to be give as the accuracy result. So How does this going to be looks like means number of the observation by, or else you can say number of the calculated observations by total number of the observations, or number of the predicted observations by total number of the observations. So that's how the accuracy mean by. And whatever the misclassification rate is, 1 minus accuracy is a misclassification rate, obviously. So whatever the accuracy you got, it is going to be 100% minus, right? Obviously, misclassification rate is whatever you miss it, that accuracy you are getting, but what exactly you miss it for. And also something called recall and precision. This terms also be very helpful in terms of you want to be get to know about how often the prediction is correct, and the negative side and also the positive side. So in the recall wise, we're going to be look out for more in terms of the negative side, how often this going predicted is correct or not. So this formula is also be looks like TP by TP plus FN. So I think you are going to see this in upcoming classes, but just for now, I'm just recalling this. And specific is also the same part, I can say, but in terms of whatever the actual value you have, that is going to be positive. Remaining everything is same. So precision is also be same part of the recall. So here we are going to be checked with the whatever the prediction kind of thing, like positive results, whether it's going to be predicted correctly or not. So F1 score is some harmonic mean of the precision and recall, like precision into the recall by precision plus recall. This all are formulas, okay? These are not we need to say some kind of theoretical nature, but these are all formulas. But by using some data set, we have to be get to know about that. And something called IUC ROC results. This is also one of the good KPI matrix for the classification task. So this plot is going to be help us to understand the plot between the TPR and FPR. So that is the specificity and the sensitivity. So this will going to be give as probability scores. Okay. So some of the probability scores consist of above of the zero point 0.5 results. We can take the consideration. Otherwise, we can ignore that whatever the curve you are going to get. But here we are getting something above the point. So let's see that how does this going to be looks like. So this is the um, Wikipedia page. I can say this Wikipedia page for the EUC ROC result to just to understanding purpose of this image. So this is the 0.5, okay, random classifier, or you can say dumb model. So if you are going to get the curve like this, you are going to ignore that model in a time, okay, because that is not at all going to be help us. So whenever you get some kind of value around or above of this zero point 0.5 result, that will going to be help us to understand you are getting ROC result correctly or not, because it's going to give as the probability scores which is lies between 0 and 1, obviously. So this is going to be help us to understand if it is a curve like this, it is much makes sense about that. If it's a curve like this, it's some kind of nature to know about something called AUC result. So if it is like this curve, blue curve, that is much appreciated, I can say, because you are getting very good AUC ROC results in terms of the classification task. That might be a best perfect class for the if you get one result for the UC ROC result, but you never get one in terms of the case studies. So yeah, that's how the KPI matrix is all about.